So the first thing we'll do here again is get rid of the radicals and write them as exponential functions. So this is going to be 27 to the 1/4 times 3 to the 1/2 times 81 to the 3/6. But we know that 3/6 is actually 1/2. Okay? And so we have to find a way of writing these two with a base 3, and we can. 27 is 3 cubed to the 1/4, 3 to the 1/2, and then 81 is 3 to the 4th to the 1/2. Okay, so now multiply the power to power. So like right here you have power to power, and here you have power to power. So it's going to be 3 to the 3/4 times 3 to the 1/2 times 3 squared. So now we're going to add all the exponents together. So 3 to the 3/4 plus 1/2 plus 2. I'll put a 1 underneath so we could add it all together. The common denominator is 4, so this one gets multiplied by 4 over 4, this one by 2 over 2, and so we have 3 to the 3/4 plus 2/4 plus 8/4. So that gives me 3 to the 13/4. Okay? Now, whenever the numerator is bigger than the denominator, that means that the radical, if you change it back to radical, it would not be simplified. So what we have to do is change the exponent to a mixed number. So you get 3 and 13 over 4. 4 goes into 13 3 times with the remainder 1, right? So it's like 3 plus 1/4, correct? So now this one we kind of go backwards and we say, okay, so that means that it equals 3 times 3 to the 1/4. Sorry, 3 to the 3rd times 3 to the 1/4. So that's 27 times 3 to the 1/4. So this would be the most simplified answer. Okay, so on this one we just have to simplify using the properties of nth roots. So what I'm going to do is notice how all the indices are 4. So I'm going to write this as one big 4th root radical, like this. You can do that. And notice how 6 goes into 216 36 times. So 6 goes into 216 36 times. So now you have 36 times 36, and 36 could be written as 6 squared. So you've got 6 squared times 6 squared. Well, that's 6 to the 4th. And so this is 6 to the 4 over 4, which is 6 to the 1, which is 6. Alright, so the 4th root of 4096 is actually 8. So I could rewrite it like this. And then I have 6 x's inside, so I could break it up so that I separate it into groups of 4 like that. And then I still have 2 left over, so I'll separate it like that. And then the y, whoops, forgot the radical. So the 4th root of y to the 8th. Okay? Which, let me just write, it's fine. So now 8 is the 4th root of 4096, so this one comes out as 8. This one comes out as x. This one stays like this for now. And then this one, this is actually y to the 8 halves, right? I'm sorry, 8/4, so it's actually y squared. And so this one right here, 8xy squared, is x to the 2/4, right? But x to the 2/4 is really x to the 1/2. So a more simplified way of writing this would be the square root of x, because that's what x to the 1/2 equals. So there's the answer. Alright, since they both have 3 as their index, I'm going to write it as one big cube root, like that. And then remember, when you're dividing, you subtract the exponent. So for the x, it's 8 minus 2. So, let's write it right here. 8 minus 2. And then for the y's, it's 4 minus 1. So then that gives you the cube root of x to the 6 times y cubed. And then we could separate them. And that would be cube root of x to the 6 times cube root of y to the 3rd. And remember what this means. This means x to the 6 thirds and y to the 3 thirds. So this is x squared y. Okay, so I'm going to write this as one big radical because they both have index 5. So 5th root of 125 times 25v over w to the 6th. Okay, so notice that here 25 is 5 squared and 125 is 5 cubed. So I'm going to write it like that. This is 5 cubed and this is 5 squared, and this is just v. And then this one I'm going to separate it into y to the 5th times, w to the 5th times w. That's still w to the 6th, right? So now I can put these together, and I have 5 to the 5th times v over w to the 5th times w. So when I separate these, notice how both of these have, let me use a pointer, both of these are written to the 5th power. Okay, so I'm going to separate that one. They're both to the 5th, so I could write it like that, right? And then 5th root of v to the w, v over w. So this first one right here, this cube root of something to the 5th just leaves you with the inside, with the radicand. So it's 5 over w. And we're going to have to multiply. See, I can't have a 5th root or any nth root in the denominator in any of the numbers or variables like I have here with a w. It's like w to the 1/5, right here, because it's in the denominator. So I'm going to have to multiply by, I need 4 more w's in order to get this one out, because I need total of 5, right? I only have 1. So I need 4 more to get this w out. So I'm going to have to multiply by 5th root of w to the 4th over w to the 4th. That's called rationalizing the denominator. So now when I put these together, use a different color. When I put these together, I'm going to get, don't forget the 5 over w. I'm going to get 5th root of v times w to the 4th over w to the 5th. So now this denominator could come out, the w. So I'm going to have 5 over w squared times 5th root of v w to the 4th. So that would be the final answer. Alright, so for part A, we have to choose all the ones that give you a square root of 2 as an answer. So for part A, we can rewrite this as 2 to the 4/8, which is 2 to the 1/2, which is the same thing as square root of 2. So A is good. For B, we subtract the denominator, the exponents, right? So this is 2, 3 minus a negative 5 halves, which is 2, and that makes it positive, right? 2 negatives. So 3 plus 2.5 is 5.5, so that's going to be 11 halves. So that's not good. And C, notice how they have the same exponents right here. So I could put these together like this: 4 times 2 to the 2/3 to the 1/4. So this gives me 8. Now when I multiply 2/3 times 2/3 times 1/4, I get 2/12, which is 1/6. Okay. I can write this as, let's see, 8 I can write as 2 to the 3rd to the 1/6, so that's 2 to the 1/2, which gives me square root of 2. So this one works. Okay, for D, let's see, I have 2 to the 2/3 over 2 to the 1/6. I'm going to subtract the exponent, so this is 2 to the 2/3 minus 1/6. So I need a common denominator, so I'm going to use the common denominator 6. I'm going to multiply this by 2 over 2. So then that gives me 2 to the 4/6 minus 1/6. So that's 2 to the 3/6, which is 2 to the 1/2, which is square root of 2. So this one is also good. Okay, the last one, 2 to the negative 3/4 minus negative 7/4. So that becomes positive. So 7/4 minus 3/4 is 4/4, which is just 2. So this one, make sure I copied it wrong, right? Negative 3/4. Oh, but you know what? I forgot the square root. I just realized it. Sorry. So this part is right. It's just I still need I didn't put it all under the square root. That was my first step. So then that's still to the 1/2, right? Because that's what this means right here. So it's 2 to the 4/8, which is 1/2. So it's a square root of 2. So that one I almost got wrong, but that one works too. So on number 20, they want you to isolate the v, so to separate it from, from the other terms. So what you do is you take 12 pi, and then 3 over 16 pi to the 2/3, and then v to the 2/3. Remember, when you take it out of the parentheses, the 2/3 goes along with it. So this is the first part that they want. They just want you to separate the v. And then it says write the approximate model. So that means that we have to take a calculator. Cannot do this by hand. You take a calculator to figure all this out. So what you would do first is take your calculator, take 3 divided by 16 pi, and then hit equal, then do the exponent key, and then put parentheses, 2 divided by 3, close your parentheses, and then times 12 pi. Don't forget the 12 pi. So when you do that, when you take those steps, you're going to find that, and they want to round it to nearest hundredth, so that means 2 numbers after the decimal. So remember these little, I messed up on that. These mean like approximate equal to or approximately equal to. It's going to be 5.76 b to the 2/3. Okay? And then for part B, they want you to use a graphing calculator to graph this. So you can, like I said, Desmos is the easiest one. And then it says, what's the surface area in square feet for a tank with a volume of 150 feet squared? So you're going to put into your calculator 5.76 times 150 to the 2/3. And so you're going to get approximately equal 162 feet squared.